Welcome all. In this video, we'll discuss some basic formulas or concepts followed by the previous year assignment questions. Some maximum questions will be asked for your end examination, NPTEL examination. We'll discuss week by week. So coming to the week 1, supervised learning. Supervised learning is a type of machine learning where the model learns the mapping from input X to output Y using labeled data, that is input is X, output should be Y. Keywords is predict, forecast based upon the past data. Surely you'll be getting some 5 to 6 marks from these concepts: supervised learning, unsupervised learning, and reinforcement learning. So if the word predicting comes, we can say that it is a supervised learning technique. And in supervised learning, we'll be having two classification: regression, two things, regressions and classification. So example, predicting house price from futures, predicting if email is spam or not, predicting disease from medical scan, that is input will be there, output should be Y using labeled data, forecast temperature. And coming to the unsupervised learning, it's a type of machine learning where the model learns the patterns or the structure from an unlabeled data, or simply we can state as group data or hidden structure. So there will be no Y exists. Keywords are group, cluster, segment, dimensionality reduction, etc. So some examples: grouping customers, clustering news articles into topics, dimensionality reduction using PCA. So regression, it is a one type of supervised learning where you will be having Y is continuous numerical value. That is, the output is a number, continuous value. So output is a number, not category. That is, keywords are continuous, quantity, predict, etc. So predicting house price. So it is a number. We can say it as a regression. Predicting temperature, once again number. Number of COVID cases, numerical. Predicting rainfall amount. And coming to the classification, there it is output Y is a discrete category or label, whereas regression output is a continuous numerical value. So classification, either discrete category or yes or no, discrete 0 or 1, or we can label it. That is, output is a category, not a number. Regression means it should be continuous number, continuous value, and output should be a number. Spam or not spam. So classify, categorize, identify, these are the keywords. Cancer, no cancer, positive, negative sentiments. So coming to the last, reinforcement learning, where the agent learns to make decision by interacting with an environment and receiving rewards or penalties. Maximum in the questions, agent, reward, feedback, like the key terms will be there. So it is a trial and error method. So keywords, agent, environment, reward, penalty. So playing chess, playing go, self-driving car, drone flight. So coming to the linear regression, the formula is y is equal to beta naught plus beta 1 of x1 plus beta 2 x2. Beta we can calculate with this formula, one of the important formula, x transpose x inverse into x transpose of y. So knn, k nearest neighbors, the distance can be calculated by using x1 minus x1 bar whole square and x2 minus x2 bar the whole square. Coming to the bias and variance, if it is overfitting, I will be having low bias, high variance. Underfitting, I will be having high bias, low variance. So bias and variance formula, this formula also they had asked in several examinations. So coming to the previous year questions, they given the data set. Surely this type of KNN questions will be asked for the in the examination. So we can easily score the marks. Given the following data set, k is equal to 3, use the KNN regression, find the prediction of the new data set 2, 3, use the Euclidean distance. This is the formula for Euclidean distance. Three distances will be there: Manhattan distance, Hamming distance, Euclidean distance. We will not be using only the cosine similarity. Other distance will be using. Maximum will be using this Euclidean distance. X2, x1, y, and this one we have to take it as x1 dash. This is the value of 3 denotes the x2 dash. So the formula is root of x1 minus x1 dash whole square plus x2 minus x2 dash the whole square. X1 value is 2, root of 2 minus 2 whole square plus 5 minus 3 whole square. Like that you have to calculate for all the values. This is x1, this is x2, and this is x1 dash, x2 dash. Once if you calculated all the values, they are given the value of k is equal to 3. You have to find the nearest three values which are more or less close to this values. Then you have to take the average of it. So you're taking the average, for example, 3.4, 3 and 2.8 means. So this will be the nearest value. You have to take the average of it. Since k is equal to 3, 3.4 plus 3 plus 2.8 divided by 3, I will be getting this 2.8 as an answer. Similarly, another problem. So try to solve these types of problem. Surely you will be getting, you can easily score the marks. X1, X2, and this is the X1, X2 value. So X1 minus X1 dash whole square plus X2 minus X2 dash the whole square. Once again using Euclidean distance. Here k is equal to 3. Once again you have to get the nearest value and you have to take the averages. For example, 2.65 plus 1.95 plus 1.45 divided by 3. For this question, the answer is option D. The same type of problem. Three classes 0, 1 and 2. X1 and X2 are independent. So this is the X1 value, this is the X2 value, this is the X1 dash, X2 dash. Here k is equal to 5. So we have to take the values which are nearer to 5 and we have to take the average divided by 5. So the option is 1. As I told earlier, these type of questions will be definitely they will be asking in NPTEL exams. So which of the following is an unsupervised learning? Unsupervised, I already told that uh, grouping, clustering, so identifying close communities, that is a group of people, the social network. Unsupervised, learning to generate artificial human faces using the faces from a facial recognition dataset. From the dataset, you are Predicting coming means we'll be making as a supervised. Forecasting, once again, it will be coming in the supervised learning, that is a regression. Sorting, once again, it will be a supervised learning. So unsupervised learning, these are the two options. And coming to the next one, reinforcement learning. So you can see the question, agent, the RL agent use the chess. We are already seen an example. RL can be used in autonomous driving system. So these are the two options. So which of the following is a regression? Regression, as I told, output is a continuous value number. Output is a number. This one we can predict yes or no, spam or not spam. So predicting the new COVID cases in a given period. Once again, a numerical value. So this is a regression, and this one total number of goals, numerical value, regression. Identifying languages, yes, English or Tamil, so you can, it will not be coming under regression. Classification. So which of these is a classification? Read the questions fully. Predicting whether or not a customer will repay, yes or no, or then forecasting the weather, it is a continuous value, so it comes under regression part. Predicting the price of a house 10 years after it is constructed, then predict if house will standing 50 years after it is constructed. So the options B and D. Once again, questions based upon this supervised learning. If it is the word clustering is come, we can simply take it as unsupervised learning. Weather forecast, predicting the term, so it will be a supervised learning from B and C. Regression, predicting the weight of a giraffe based on its weight. So next one is week 2. So the design matrix, this is the formula, one of the important formula, and these type of questions will be asked. So x of n cross p plus 1, that is given a training data set of 500 instances where each instance having 6 dimensions and each output being a scalar value, the dimension of the design matrix used. So total is 500, n is 500, 500 into 6, p is equal to 6. So 6 plus 1, I'll be getting 7. Don't forget this formula. This type of questions will be asked. Once again, the same type of questions, 10,000, 12 dimension, and each output having 3 dimensions, the design matrix. 10 is equal to 1000 into 3 plus 1. 12 plus 1, I'll be getting 30. This type of equation we are already seen in the first unit. Normal closed form solution, and the cost function is j of theta is equal to I is equal to 1 to n, actual minus predicted whole square. Which of the is true about the cost function used in the linear regression? That is, it measures the sum of squared differences between the predicted and the actual values. So which of the condition must hold for the least square estimated in linear regression? That is, the error must have a mean of 0. And in ridge regressions, the regularization, I will be using two regressions, ridge and lasso regression. Ridge shrinks the coefficient, but never it will become 0. This is the error term plus this is the coefficient term. So large lambda means bias increases, variance decreases. Lasso regression, I'll be taking the magnitude. So forces some coefficient to 0. If this term is 0, lambda is equal to 0 means. So some coefficient to 0. So mainly for future selection. Ridge regression shrinks the coefficient. Lasso makes sum is equal to 0. So which of these is true from the following? The options are C and D. Ridge is more stable. They are already mentioned here. Stable. Then lasso is better suited for probability than ridge regression. And these type of bias and variance questions also will be asked surely. Bias increases, variance decreases. So bias is high, variance is low. One of the most important topic in the second unit, subset selection. So types will be best subset, most expensive, forward stepwise means moderate, forward stagewise means it is the cheapest. So this question is asked in the this number of models is equal to O of 2 power p. So these are the previous year question paper assignment questions. So subset selections are more likely to improve the test error by focusing on the most important feature than variance. As I told, three subset selections method: most expensive, forward stepwise means moderate, forward stagewise means cheapest. Option B, forward stepwise selection, then followed by forward stagewise regression and best subset selection. This question has been asked in their end exam also. To consider the forward selection, backward selection, once again the same thing, the same type of questions. Best selection can be computationally more expensive than the forward selection. And other part is your PCA, principal component analysis, is the objective. Argument max of summation of I is equal to n, v power t x of I whole square, set for all v equal to 1. Larger negative coefficient means we can neglect it, unimportant. So least square objective, the formula is minimum of I is equal to 1 to n y of I minus f of xi whole square. So coming to the week 3, we'll be having some logistic regression. This is the formula. And main thing is the probability is from 0 to 1. It will uses the sigmoidal function. The important thing, sigmoidal function is the log likelihood formula. L is equal to y log p of x plus 1 minus y log 1 minus p of x. And this is the most important formula. Surely a question will be coming in this by using this formula. Your likelihood or your maximum likelihood condition, summation of p of I power y of I into 1 minus p of I power 1 minus y of I. And this formula is also important for a polynomial degree. Minimum degree is equal to number of classes minus 1. For multi-class classification using linear regression, argument max of p of I. And for linear dependent analysis, I will be using this formula. J of W is equal to SB by SW, that is SB is the between class variance and SW will be within class variance. This is also one of the important formula where we will be calculating the prior probability. P of Ck of k is equal to number of samples class C of k divided by total samples. We will see some examples, you will be able to know. So these type of questions will be definitely they will be asking in the end semester. So, end examination, NPTEL exam. Y of I they are given. P of x of I they are given. This is the formula. The likelihood, compute the likelihood observation. Summation of P of I is 0.8 power 1 into 1 minus P of I is 0.8 power 1 minus 1. So these two terms are 0. I can, if I am multiplying with 0, it will become 0 plus 1 in 1 power, sorry, 0.9 power 1 into 1 minus 0.9 power 1 minus 1. So like that you have to calculate it. You have to apply this formula. They will give these values. You have to apply this formula and you have to substitute the values and you have to get the answer. For this problem, the answer is 0.288. So logistic regression is true. As we told, linear model is transformed the range of 0 to 1 by a sigmoidal function. Parameters are learned by maximizing the log likelihood. This is about LDA. You can refer this one. This is also possibility of asking that it maximizes the interclass variance related to the intra-class variance. Same direction of the spreading hyperplane. They asked about hyperplane. The 1 is equal to sigma of 1 is equal to 2. As we told, this is also one of the important problem where we'll be finding the prior probabilities of class A and class B. They are given some features. They are asking what is the probability of class A and what is the probability of class B. So this is the formula, number of samples in class A divided by total number of samples. So A 2.3, 1.8, 3.2, 3, 2.1. So totally 5 values. In B 2.7, 1.9, 2.4, total 3 values. So all it total is 8. So probability of A is equal to 5 by 8. Probability of B is equal to 3 by 8. Coming to this problem, in a 3-class classification problem using linear regression, the output vectors for 3 data points are, they are given some data points. So predicted class is equal to argument max of y of j. So in the first vector, check which is the maximum value, 0.8. So it is a class 1. Position 1, so it denotes class 1. In second vector, it is 0.6. Position 2, so class 2. If it is position 1, once again I will be getting class 1. Point minus 0.1, 0.4, 0.7. The maximum value is 0.7. Position 3, class 3. So the answer will be class 1, class 2, class 3. What is the minimum degree of the polynomial should use? If it is a 5 class, n minus 1. So the answer will be 4. So one problem based upon log likelihood, they are given, this is the formula, y log p plus 1 minus y log p 1 minus p. So given data, probability is 0.4 and y is equal to 1. Just apply in this, you'll be getting the answer. And the next one is for the two classes C1 and C2 within class variance respectively, they are given the means, find the Fisher criterion J of W. S of B divided by S of W. S of B is equal to mu2 minus mu2 dash minus 4 dash whole square, that is between class, and this one is within class plus all the values they are given, just calculated, will be getting 0.8. The other problems are mu1, mu2. Identify the matrix I. So what is the direction vector? Direction they are asking, vector W. Here generally W is equal to mu2 minus mu1, and also they are given us identity matrix. S of W is equal to identity matrix. So W is equal to mu2 minus mu1, which is 5 minus 2, I'll be getting 3, 7 minus 3, I'll be getting 4. They are asking the direction, so I will be calculating the magnitude. Okay, root of 3 square plus 4 square is equal to 5. So the unit vector will be, there it is 3 by 5, there it is 4 by 0.6 and 0.2. Coming to the week 4, main thing is about perceptron, the distance from hyperplane, and then support vector machine, maximum margin, future space dimension, important formula. So the context of soft margin SVM, what happens to the number of support vector as the parameter C increases? If we are increasing the C, it generally the decreases. The number of support vector decreases. And from the data set, the endpoints in D dimension, what is the maximum number of support hard margin SVM is N. The same type of question has been asked. What is the dimension? I mentioned here. For these type of questions, they will be giving some data set. From the data set, you have to calculate it. These types of questions will be asked. Another example. And in week 5, the main thing is about neural network Bayesian formula. So parameters is equal to input into hidden plus hidden into output plus the bias terms. Important formula this is. And bias formula, I think many of them will be knowing. P of A given B is equal to P of B given A into P of A divided by P of B. Here they mentioned as theta and B. This is the formula for MLA and MAP. Mean formula, mu is equal to 1 by n summation of x of 5. Geometric distribution means P is equal to 1 by x bar. So gross entropy loss h of p minus q is equal to minus summation of p of I log qi. So given a 3-layer neural network which takes 10 inputs, 5 hidden units and output of 10. So input is 10, hidden 5, output is 10. Just applying the formula, input into, just applying this formula. Input into hidden plus hidden into output plus bias terms. 10 into 5 plus 5 into 10 plus 5 plus 10. So I'll be getting 1.5. This question is important. They asked last year in the final exam. Based upon your Bayesian formula, P of theta given d is equal to P of t given theta to P of theta divided by P of d. They are asking which is correctly identify each term in this formula. The answer is this one. Theta of d is the posterior, P of theta is likelihood, P of theta is prior, and P of d is the evidence. Formula. I'm using a feed-forward neural network that performs regression in a p-dimension input to produce a scalar output. So they are asking what is the total number of trainable parameters. The answer is pk plus m minus 1 into k square plus. So coming to the next week 6, the entropy formula. What you have studied in one of the important formula, entropy, information gain, and the misclassification error. Entropy formula is h of p is equal to minus summation of p of I log 2 into p of I, and information gain h of parent minus summation of n of I divided by n, and h of child. Misclassification error is equal to 1 minus maximum of p of I, and this formula is also important. Splits is equal to 2 power cube minus 1 minus 1, and if you are doing too much of pruning, will be going for underfitting. Free height versus variance means free depth increases, variance also increases. So increasing the pruning strength in a decision tree by reducing the maximum depth. So might lead to underfitting if it's set too aggressive. Here also I mentioned here, too much of pruning leads to underfitting. So what is the common indicator of overfitting in decision tree? So the training accuracy is high, while the validation accuracy is low. Entropy of 50 split classes between two classes is 1, and 90-10 entropy for 90-10. 50-50 means it is 1, 90-10 means it is 0.46. The problem which I told, 2 power q minus 1, q minus 1 minus 1, 8 unordered values. So 2 power 8 minus 1, 2 power 7 minus 1 will be getting 127. And Coming to this part, most important thing, surely you'll be getting a question related to either Gini index, your information gain, or entropy. Here they ask the initial entropy, and for the same data set they ask the gain of the this part. So practice sums like this. Surely you'll be getting a sum based upon gain, entropy, or Gini index. So entropy formula you'll be knowing. So from the table I'm classifying as Maligan 1, this one 5 times, and for 0 it is 7 times, total is 12. So probabilities P of 1 is equal to 5 by 12, P naught is equal to 7 by 12. Just apply in the formula, we'll be getting one value 0.9798. Why I am calculating malignant means the question they clearly mentioned that initial entropy of the malignant. If it is vaccination, we have to calculate this column. If it is size, if it is site. Now, information gain h of parent minus summation of ni by n h of child. So here information gain of vaccination. So case 1, vaccination is equal to 1, this one, and case 2 I will be going for vaccination is equal to 0. Once again, for vaccination is equal to 1, what is the malignant? Like that you have to calculate it. Malignant 0, 6, malignant 1 is 0. So h of h is equal to 0, so pure no. For vaccination is equal to 0, I will be getting this h value. So weighted entropy h split, that is 6 by 12 into 0. 6 is this one, divided by 12, total value as 6 by 12 into this value. So then you have to calculate the information gain h minus this 0.32. So week 7 easy one, I think maximum students can score in this. Your impression matrix, true positive, true negative, false positive, false negative, formula for sensitivity, specificity, precision, recall, and this one is for accuracy. Predicted, actual. Predicted is actual is true positive. Predicted no, actual is means false negative. Predicted no, so false. Actual it is yes, so negative, false negative. Predicted yes, actual no, so false positive. Predicted no, actual no, true negative. Coming to the ROC curve, x-axis is the false positive rate, y-axis is the true positive rate. Cross validation, k-fold will be splitting into k parts. Each fold is equal to same direction. So bootstrapping, ensemble methods, and stacking. Ensemble, bootstrap samples, train in parallel, reduce variance. Boosting, sequence training. Here parallel training, here sequence training cannot be, this one cannot be parallel, it's a sequential. Backing, reduce variance. posting, reduce bias, tackling combined models. Some questions based upon this one. Posting is an example of ensemble method. Posting may assign unequal weights to the prediction of all weak classifiers. The individual classifier in posting cannot be trained parallelly. About bagging, and this this type of question also will be asked surely. Given 100 instinct data points, your sample times with the replacement, what is the expected probability of not selecting a point in 100 trials is equal to 99 by 100 power 100. So probability of selecting a point at least one in 100 trials is equal to 1 minus this one. So the expectation is summation of x into probability of x, so 100 into its value 1 minus, approximately you will be getting 63. Try to solve more problems this like this. Question based upon bootstrapping. So these things, accuracy, precision, recall, you can easily score marks. They are given the true positive, false negative, false positive, true negative. They ask the precision, recall, accuracy. And week 8 is about random forest, multiple tree and randomness, boosting, sequential, bagging means parallel, gradient constant, residual error, Bayes rule. Yeah, probability of A given B is equal to probability of B given A into probability of A divided by probability of B, and it's also one of the formula. A given E is equal to probability of E given A divided by E given A plus E given B plus E given C. And this maximum questions will be asked in graph part. This is also one of the important formula. Multi-class logistic regression parameter is equal to k minus 1. Just analyze the graph and we have to answer it. So the options are A and D. D is independent of B. D is independent of B when C is known. When C is known, D is independent of, and other one is A is independent of B when C is known. A is independent of B when C is known. Try to find the edges and vertexes and their connections. You can answer them. Random forest to decrease the correlation between the trends. Six classification problem. So what is the formula? K minus 1. So 6 minus 1 I will be getting 5. Week 9 is your parameter counting. Parameters K minus 1 to summation of parent states, and important formula is HMM, hidden Markov model. The same type of questions, edges. You have to find which one is independent and which one is dependent. The same type of question. A and B are independent if no other value are given. A and F are independent if C is given. This one is for propagation. So coming to week 10, The main thing is k-means algorithm. We are already seen this formula, minimum of x of y minus p of k the whole square. So hierarchical clustering, single link means minimum distance, complete link means maximum distance. Average link is equal to average distance. So this is the formula for single link, minimum distance, complete link, maximum distance, and read this formula thoroughly for Birch algorithm. Cluster n comma sum comma s of s. Centroid mu is equal to sum by n. Radius is equal to root of ss by n minus sum by n whole square. Combined cluster and Cure algorithm, multiple representative points, handles non-convex clusters and outsiders. Other algorithm, uh, question based upon probability. Purity is equal to number of data points most frequent class divided by total number of data points. So the answer will be 0.6. They ask the formula for Birch algorithm. So this is the radius formula. And these type of questions also will be asked surely in your final examination using clustering algorithm. Either will be using single link or you can use complete link. So these are the values. You have to find which cluster, how the cluster will be made. So closest point pairs P3, P4 is equal to 1, P5, P4. You have to reduce it one by one so that at last you will be getting a, you will be able to combine into clusters. Same problem with some other data, same type of data. So week 11 is about GMM, Gaussian mixture model, and your geometric distribution, normal distribution, geometric distribution, etc. Mean covariance matrix P into P plus 1 divided by 2. GMM is the answer. And what constraint? Mixing coefficient of phi of k, that is summation of phi of k is equal to 1. And another sum based upon this GMM cluster 5-dimensional. So the last will be maximum, it will be on your dimensionality reduction, PC dimension, or questions will be from or reinforcement learning. So what is the VC dimension of the class of linear classifier in 2D space? 2D space means 3, 3D space means 4, 4D space means 5. Like that you can answer. High bias, low variance. And check this type of questions also. Reinforcement learning plus 5 reward once the target reaches it. And the same type of reinforcement learning uh, by right hand, left hand, you have to calculate this is the formula for this question. V of s is equal to 0.9 maximum of V of SL into comma V of SR. You have to calculate one by one. Try to solve problems like this. This also will be repeated for your final examination, and this question Surely they will be asking in the final examination. Given 50 hypothesis function, each trained with the 5 power 10 power 5 samples. What is the error greater than 0.01? Square. So the dimension will be 5. Square means 4 side. So dimension will be 5. Once again, same problem based upon this. They carry out, solve this both the problem, or took out this, solve this type of problems for lectures like this. Kindly subscribe the channel. Thank you.